Hi children, once again welcome back to my YouTube channel Chemistry Pocket. Myself Sreelatha. In this class, I am going to explain oxidation states of 3D series elements. Let us see the oxidation states definition. The definition of oxidation states is the total number of electrons that an atom lost or gained in order to form a chemical bond is called as an oxidation state. That is nothing but for the formation of a chemical bond. That means how an atom can form a bond means by the loss of electrons or by the gain of electrons. So how many number of electrons it was lost or how many number of electrons it was gained. That number is called as an oxidation number or oxidation state of that particular atom. So oxidation state is nothing but the total number of electrons that an atom lost or gained in order to form a chemical bond is called as an oxidation state. So here an element can show two types of oxidation states. One is an positive oxidation state and another one is a negative oxidation state. When it show positive oxidation state means when it lost electrons for the formation of a chemical bond, it can show positive oxidation state. When it gained electrons, so in the bond formation, that number is called as a negative oxidation state. So an element can show two types of oxidation state. One is in positive oxidation state or negative oxidation state. When it will show the positive oxidation state means by the loss of electrons. When it lost electrons, it can show positive oxidation state. And when it gained electrons means it can show negative oxidation state. Okay. So next let us say about the variable oxidation state. Next topic is variable oxidation states of 3D series elements or variable oxidation states. It is a variable oxidation states. So what is in variable oxidation state? The definition of a variable oxidation state is nothing but it is a number. It is a number that determines the charge on an atom depending upon certain conditions. Depending upon certain conditions is called as a variable oxidation state. So variable oxidation state is nothing but it is a number that determines the charge on an atom depending upon certain conditions is called as a variable oxidation state. It is nothing but, so here one element only can show the different oxidation states in different compounds under certain conditions. That is called as a variable oxidation state. It is nothing but same element can show different oxidation states in different compounds under certain conditions. That property is called as an variable oxidation states. And here the one more point regarding this variable oxidation, that means here the same element can show the different oxidation states in different compounds under certain, that means depending upon the conditions the element can change its oxidation state. Okay, that property is called the variable oxidation state. So one more point for this variable oxidation state is here the D block elements or especially the transition elements can show successive oxidation state differ by unity unlike P block elements. So it is nothing but, so when we observe the oxidation states of P block elements, so here the transition elements can show the successive oxidation states differ by unity unlike P block elements. What is the meaning of this point means? So when we observe the P block elements, so for example take group 13 elements. So group 13 elements can show the two oxidation states as +1 and +3. And here the difference in the two oxidation state is 2. So what is the difference in these two successive oxidation state is 2. And take the group 14 elements. Group 14. So for group 14 elements also they can show +2 and plus 4 oxidation state. So in this one also, in the group 14 also, the difference in between the two oxidation state is plus 2. So when we observe the oxidation states of D block elements, now let us see the oxidation states of D block elements. So in this one, when we observe the oxidation state of D block elements, they can show the oxidation states as plus 2, plus 3, plus 4, plus 5 like this. It is nothing but the difference in between the two successive oxidation state is only 1. Only 1. It is nothing but when we observe the P block elements, the difference in the two oxidation states is 2, and in the D block, whereas in the D block elements, they are showing the different oxidation states in different compounds, and the different oxidation states is differ by only unity. Only one number is different. That means plus 2, plus 4, plus 2, plus 3, plus 4, and plus 5. So this is called as successive oxidation state differ by unity, unlike P block elements. So let us see the reason. That means here the D block elements, or especially the transition elements, are showing the variable oxidation states. Variable oxidation state. That means these are showing number of oxidation states in different compounds. The same element only showing the different oxidation states in different compounds. So let us see the oxidation states of 3D series elements. The series elements are scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. So these are the 3D series elements. So here the scandium can show only the plus 3 oxidation state, and the titanium can show plus 2, plus 3, and also plus 4 oxidation states, and that vanadium can show plus 2, plus 3, plus 4, and plus 5 oxidation states, and chromium can show plus 2, plus 3, plus 4, plus 5, and also plus 6, and manganese can show plus 2, plus 3, plus 4, plus 5, plus 6, and also plus 7 oxidation state, and iron can show plus 2, plus 3, plus 4, and also plus 6 oxidation states, and cobalt can show plus 2, plus 3, plus 4, and nickel plus 2, plus 3, plus 4, and next copper can show plus 1 and plus 2, and zinc can show plus 2 oxidation states. So these are the oxidation states shown by the 3D series elements. So observe these oxidation states. So here each element is showing the more than 2 oxidation state except scandium and zinc. Except scandium and zinc, the remaining all elements are showing 2 or more oxidation states. Okay, and the difference in the successive oxidation state is also only unity. Why these? That means that this particular property we are not observed. That means we didn't observe in the P block and also S block elements. Why the D block elements are showing this type of property means, the reason is, that means the D block elements are showing the variable oxidation state property. Why these are showing the variable oxidation state means, the reason is the energy difference between Ns and N minus 1 d orbital is very less. Or the energy difference between Ns and Ns and N minus 1 d orbital is very less. So that's why the number of that means the electrons which are present in the valency shell of s orbital and in the penultimate shell of d orbital both are involved in the bond formation. So that's why they can show this type of variable oxidation states. That means this many oxidation states in their compounds depending upon their the conditions. Okay, so it is about the oxidation states of 3D series elements. And next here, and also here, see here, scandium is showing only one oxidation state. It is in this total 3D series, scandium is not showing the variable oxidation state. Scandium and zinc are not showing variable oxidation states. These two elements are not showing variable oxidation states. Okay, and especially scandium, when we observe the scandium, it is a transition element. So only one transition element in the 3D series not showing the variable oxidation state is scandium. In entire D block, that means entire in the 3D series means we can consider as a scandium and zinc. Okay, and next, the most common oxidation state in the 3D series is, the most common oxidation state is plus 2. It is a most common oxidation state of 3D series. And then after the most common oxidation state is plus 3. The first most common oxidation state is plus 2 and the next most common oxidation state is plus 3. Okay now. And next one is the least oxidation state is plus 1 shown by the copper. Shown by the copper. And it is nothing but the lowest oxidation state. The lowest oxidation state shown by the copper, that is plus 1. And plus 7 is the highest oxidation state shown by the manganese. Highest oxidation state in 3D series. In 3D series is the lowest oxidation state is plus 1 shown by the copper and the highest oxidation state is plus 7 shown by the manganese. And here, which electrons are responsible for showing of an lowest oxidation state is Ns electrons. Lowest oxidation state is shown by, that means lowest oxidation state is equals to number of Ns electrons generally. Number of Ns electrons. And the highest oxidation state. And the highest oxidation state is equals to number of Ns plus N minus 1 d electrons. So, and it is applicable only up to middle only. Okay. So, it is about the oxidation state of 3D series elements. Now, let's see here the quick revision of oxidation states of 3D series elements. The definition of oxidation state is the total number of electrons that an atom lost or gained in order to form a chemical bond is called as an oxidation state. And here the element can show two types of oxidation state. One is in positive and another one is in negative. Positive oxidation state is shown by the electron when it lost electrons, and negative oxidation state it was shown when the atom gains electrons. And next one is in variable oxidation state. So variable oxidation state is nothing but it is a number that determines the charge on an atom depending upon certain conditions. So here it is nothing but the same element can show different oxidation states in different compounds under certain conditions is called as a variable oxidation state. It is one of the different property, one of the property which is shown by the D block elements or especially the transition elements. Okay, and this property we didn't observe, that means this property does not shown by the S and P block elements. So, and also the D block elements can show successive oxidation state differ by unity unlike P block elements. It is nothing but when we observe the difference in the two successive oxidation state we can observe only one. And whereas in the P block elements we can observe the difference in the two successive oxidation state is 2. Okay. So next one is these are the oxidation states of 3D series elements. Here the scandium is a transition element which is shown. The scandium is showing the least oxidation state as plus 3. And zinc is also showing the least oxidation state as plus 2, but it is not the transition element, it is only the D block elements. When we are talking about the D block elements in the 3D series, that means in the entire 3D series, which elements are not showing the variable oxidation state means we have to tell scandium and zinc. But in the first row of transition series means we have to say only scandium because zinc is not a transition element. Okay. And the reasons why the D block elements are showing the variable oxidation states means the energy difference between Ns and N-1d orbitals is very less. So that's why both the electrons, that means the valence shell electrons of s orbital and the penultimate shell of d orbitals, both are involved in the bond formation. So that's why they are showing the variable oxidation states like this. And so plus 2 is a common oxidation state of 3D series. And the next common oxidation state is plus 3. And the plus 1 is an lowest oxidation state shown by the 3D series elements, and the element is copper. And plus 7 is the maximum or the highest oxidation state shown by the manganese. And the lowest oxidation state is equals to number of Ns electrons generally. So generally we can say that if only 2 electrons are present in the s orbital, so that is the lowest oxidation state of that element. And the highest oxidation state is equals to number of electrons in ns orbital and also n-1d orbitals is called as a highest oxidation state. So this is about the oxidation states of 3D series elements. Okay students, I hope you understood the today's class oxidation states of 3D series elements. If you have any doubt, so please post Please post in the comment section. Okay. And, and please subscribe my channel Chemistry Pocket. Thanks for watching.